Hello, I'm Holly Lynn Lee, and I'm here with my colleague and friend, Webster West. Webster is a professor of statistics here at North Carolina State University, and we're going to be talking today with him about some of his experiences teaching at the introductory statistics level, and with particularly using a tool that he has developed called StatCrunch. He's been very involved in thinking about the design of curriculum materials as well as the use of technology tools throughout his career, and we're going to benefit from some of that experience and hear a little bit from him. So Webster, you are the developer of a software tool called StatCrunch, and I know that you have thought very carefully about how to design and use your software in doing statistics and developing curriculum materials around that. And one of the things that I love, as I've mentioned, I've been in your intro statistics courses, and I see you using this almost on a daily basis with your students, and they come to class with any mobile device, whether it's a laptop, a phone, a tablet, and they're able to interact with this software in that format and both analyze data that you have given them as well as enter data and doing different tasks where you're collecting data from them. And I just love seeing that in that intro statistics course. So I have opened one of the data sets that you use, and we're going to take a look at how he kind of engages his students with this data set and kind of the ways that you can use a tool like StatCrunch to actually have students think about interesting questions and tools for analysis and interpretations that they might do with a given data set. So tell me a little bit about this data set.
Okay, yeah, this data set is one that's sort of I'm personally interested in because I, at one point in my life, lived close to Lake Travis. So this is a data set about Lake Travis, which is outside of Austin, Texas.
Okay.
Just in the suburbs of Austin, Texas. It's a beautiful lake. It's in the hill country in Texas.
All right.
Very nice blue water. It has a limestone bottom, so it's a beautiful spot. The only issue with Lake Travis is that it's a variable depth lake.
Ah.
So there's a dam on one end of the lake, and water's released from the lake to provide water for irrigation for farmers downstream.
Okay.
So it's an interesting lake because you never know how much water is going to be there. So when it's there, it's nice, but when it's not, it can look a little rough around the edges.
Okay.
As the shoreline, you see more and more of the shoreline and things like that. So it's an interesting place, and as I said, I lived here close by and was interested in the data relative to the lake.
All
So
right.
I encourage my students to do this type of thing as well. You can find relevant data sources about the world very close to you. Pretty easily now with the internet.
Right, so here in North Carolina, we might look at Lake Jordan.
We could, that's
Yes.
right. Yeah, that would be another. I don't know if it's variable depth, but
Yeah.
it's probably variable, but not quite as variable as Lake Travis, as we'll see. Yeah.
So tell me a little bit about the numbers that I'm seeing in this data set and what actually was measured.
Yeah, so this is an interesting data set, first of all, because of its format. When you look at the data here, a naive student would initially think, oh, there are 13 variables here.
Oh, because I see 13 columns.
13 columns, right. So, that's one of the things you always want to discuss with your students is think about how many variables have actually been measured. In this case, it's only really three variables. So what we have here is annual measurement, yearly measurements taken over the months of each year, January through December, and it's the water level of Lake Travis, and that's feet above sea level that you see here. Is these measurements that are generally in the 600 or so range. And we have the data broken out in a very specific way here. So we've got the year in the first column. We've got 1943, and let me just scroll down here, down to 2011.
Okay.
So I haven't updated this data set since I moved from the area. I guess I lost interest. So we have year in that column. That's one of the variables. And then we have the month of the measurement, but the data is broken out in a different way here. So the months now are spread across the next 12 columns, January through December. An alternate format would be to have month as the title of a column and then January through December repeated many, many times.
Right.
And then have the actual measurement for the height of the lake, the level of the lake, in a third column. But the data in this format is a very common format that you see. The one reason I wanted to discuss this data set today is I think it's the most common format, that data that's that's accessible on the internet, this is by far the most common format, and seeing it presented in this way is
Yeah.
also very, very common.
Yeah, I have gone to different weather sites or from the NOAA and trying to look at sunset data or things like that, and this is the type of format that I see. And if you think about what kind of software package you might have access to, the format of that data, I think you're bringing up really great points that you have to think about. What exactly is being measured? How is this format? How am I going to deal with this format in the analysis that I'm going to do?
Yeah, that's right. Yeah. It's an interesting data set because the types of questions that you can types of statistical topics that you can discuss with it as well. Technically, it's a time series. So many of my colleagues in the statistics department would, apply some very advanced time series techniques with this data, but even at the introductory level, you can do some very interesting things and touch on some of those concepts in ways that I think are very enlightening for the student.
All right. Well, I hope you're going to tell us a little bit more about that. So what kinds of questions would you pose for your students to answer, or do you think students might pose with this data set?
Yeah, so what are some good questions, right? That's what I was talking about before. Ask good questions. And so, I would put this out to my class, showing them this on the screen. What are some good questions here? And, a natural question, just based on the format of the data, is, how does the water level vary over the course of the year? If you're thinking of visiting this area for a vacation or something like that, when am I likely to have water?
Right.
If I'm going to use a boat or something like that, then you want to try to visit whenever there's more water in the lake. So that would be an obvious question. Okay, and to quantify that a little bit more, we might want to say when is the water level typically at its highest point? Touching on that idea of typical. Okay, so what's a typical measurement in January, a typical level in February, March, and so on? And then which one of those typical values is the highest?
Right. So I'm looking at 12 typical values and trying to think about which of those months am I going to have the on average, the highest water level.
That's absolutely right, yeah. And then, of course, in addition to that, I was once told that that's like 10% of your job if you can teach people about comparing typical values in data sets. But maybe even more interesting question here is, can we quantify the variability? How much variability is there in the water level in January, and how do we compare that to February, March, and so on? The variability across those months would be something you'd want to understand as well. So, from a practical perspective, if you're going to visit the lake, sure, you want to go when the typical water level is high, but you also don't want to see a lot of variability in the water level in that particular month, because that could mean that,
you don't know.
You don't know, right? So
Right.
You'd like to visit when the water level is typically high with very small variation, if possible.
Yeah.
So I think those are the types of questions that I would hope to elicit out of my students based on a very short introduction from me.
Yeah.
But, so you
Maybe
think about...
show them some pictures of
Right.
people enjoying the lake when there's lots of water versus people
Right.
not being able to enjoy the lake.
Yeah, I actually have a slide somewhere that has it full and has it not so full. Unfortunately, there's been a drought in Texas over the last several years, and the lake has really suffered from that drought. So that's actually what got me interested in this particular data set. Is that, is the water level that we're seeing today, is that unusual?
Yeah.
Or is it something that we've seen maybe in the past?
Right.
Yeah.
All right. So, Webster, show us some things that you might do or have students do when they're investigating some of these questions that you just posed for us.
Sure. Okay. You got to think about when I introduce this data set, what point in the semester, and I do it very early on. So in the descriptive statistics, after we talked about things like histograms and box plots and things of that nature, basic summary statistics, mean, median, and other measures of variation, standard deviation, interquartile range, and things of that nature. But one of the things I hope to teach my students in terms of working with this very common data format, what's sort of a go-to way that you could answer those questions? What would be the standard thing that you should always think about with this particular data format? And I really like the idea of doing a box plot here.
Okay.
So I would like to do 12 box plots. One for each of the 12 months here. So we're going to do a box plot for the data in the January column.
Okay.
A box plot for the data in the February column, March, and then all the way on over to December. We want to put those box plots, the best part about box plots is they're comparative in nature. That's really what they were built for. So we want to look at all 12 and see if we can answer those questions.
So I want to see the distribution of, in December, how water levels have been varying.
Right. And then same for the other 12 months, and we want to be able to compare those distributions.
Okay.
All right, so I like the box plot here. So let's do a graph. Go down to box plot. You can see, StatCrunch, of course, does all the standard graphics for categorical and quantitative variables, and even some more advanced ones that we might take a look at in just a second. But,
Okay.
So let's choose the box plot option, and I'll select all these months, January through December.
Okay.
And now you think about how you want to draw the box plot. So, I'm a 5-number summary guy.
Okay.
All right, min, Q1, median, Q3, max.
All right.
Now, you can do it what I call a modified box plot as well, but I don't typically start with that. I look at the features of the data first with the 5-number summary, and then I come back, if necessary, and look at the modified version.
Okay.
So we can look at that maybe in just a second. All right, so we've got our 12 columns selected. We can click Compute, and here are our 12 box plots. So when you look at this picture, I think there's some interesting features here. One of the things that you can clearly do is try to compare the typical values, right? So
Right.
when is it at its highest? When is it at its lowest, typically? And if you think about those levels, how much variation is there around those levels across the months, right? And so you can, real quickly here, we can just move across. One of the things you can do in StatCrunch is you can put your cursor over a particular graphical object, in this case one of the box plots, and you can get some information about it.
Oh, there I see some of your 5-number summary.
Yeah, there you see it, right? So the median, if we're going to use that as our measure of typical, as we would with the box plot, would be 674 in January. We can move across here a little higher, 693 in February. Moving across here, we don't have to look at all these. It continues, I think, to increase a little bit in March. April, we see just a smidge of a drop down.
Well, and one of the things that my eye was immediately drawn to was how long the first 25% of our data is.
That's right. So
Yeah.
that's where variation's important, right? So is there a great month to visit when you're guaranteed that you're going to have a lot of water in the lake? The summer months would be, for any sort of lake activity, would be your optimal times to visit. But you see what happens in the summer is things heat up in Texas, quite hot in Austin. The water evaporates faster, and they let more out of the dam.
For irrigation.
And you see it dip there into September. And then when that weather pattern changes, then it starts going back up again. So this tempting time to visit is tricky. And that variation that we see here, the really long first quartile for each of these months, indicates that there's many times when the water level is very low.
Right.
Very low, right?
I can see some of those minimums dipping down below 620.
Yeah, down below 620. And when the water level is at 620 in Lake Travis, in that vicinity, you have a lot of the inlets areas that are completely dry. Yeah, so in many cases you couldn't even put a boat in the water in that sort of situation. In fact, in my experience, anything below 640 is dreadfully low in terms of the lake level.
Yeah, what I love is that I'm hearing you have this conversation about how you're interpreting these box plots directly back to the context and directly back to thinking about why we might be seeing some of the patterns that we're seeing.
Right. Yeah, that's important. If you can, assignable cause is important, right? So in this case, it's pretty easy to understand the behavior of the lake when you think about it. But I think even if you look at these medians, right, there's not a huge amount of variation relative to the total variation that you see in each of the months. But there is a lot of variation in each month. So the middle 50% of the data shown by the box, that's relatively consistent, I would say, across the 12 months, the 12 box plots, and so is the range of the data. It's relatively consistent, but you picked up on a very good point there. We've got a very long left tail. In the data for each of the months, we see this very long left tail. And in fact, when you see it in either end of the box plot, when you see that long of a segment, in this case it's the first quartile in each of these box plots, is very long. Then you might think about going back and let's see, do we have outliers that are responsible for that, or is there consistent behavior? Is there a lot of data in each of these segments?
Right. You had mentioned about that there were times where there was a drought.
Yeah, that's right. Yeah.
I'm wondering, were there particular years that are kind of contributing to that?
That's right. Yeah, that's a good question. So let's go back and let's edit our inputs. Now, this is actually one of the most important things, I think, in data analysis, because too often students expect I do this, and this, and interpret the output.
Right. Do this, I'm done. It's a
it's
linear
over.
Process.
Yeah, and it's never the case when you're analyzing data. So it's almost always the situation when you take a first look at the data, you've got to go back and, based on that look, modify the way that you're approaching the data.
Yeah.
And so in this case,
This comes from your Tukey background and thinking about exploratory data analysis.
I'm sure it
doesn't
does. I'm sure it does. Yeah. So let's go back over here, and now let's use fences to identify outliers. Let's turn on that option and see if we do have that one drought year or something that's causing those very low values there. And let's go back and recompute our box plots. So the problem is really not probably 1 year of drought, right? I'd say historically, looking at, once again, this data from 1943 to 2011, that there are many times when we've had some very low values, right?
Yeah.
So all the outliers in this case are on the low end of the data, none on the high end, unfortunately. Right. And if you think about it, I can tell you why none of the values I think are above 700 roughly, because that's the level of the dam. Okay, so you can't. There's only so much water that you can get in the lake before it starts spilling out of the lake, right? So, and so that's really, if not the exact height of the dam, it's related to the height of the dam.
Right.
Okay, so the capacity, if you will.
Right. So understanding kind of the reasonable range that one can be expecting, given that context, that it's unlikely we're going to see something above 700 because of how that lake and the dam is constructed.
That's right. Yeah, actually, you're pushing the capacity. So we don't have any of the outliers on the high end. And that's why, because you're capped in that direction. But unfortunately, for people who like Lake Travis, there are many times when it can get extremely low.
Right.
Okay, so we're managed on the high side, but not on the low side. I think there's some political efforts to maybe change that now, but at the time we're viewing this data, that's not the case. So one of the things you can do now, so we were wondering if there was a single year that was responsible for those lower quartiles here.
Yeah.
In StatCrunch, you can also, of course, highlight these values. So let's pick some of the lowest ones. Let's try this one in August, okay? Yeah, okay, so that low value was in 1951. And in fact...
So now what I'm seeing in pink are all the 1951
that's right.
data values.
Yeah, that's right. So we highlighted that point. That turns on the row in the data set.
Absolutely, this dynamic link.
And all values that are a part of that row will be highlighted. So in fact, what we're doing here is highlighting that same point in all of the box plots. And you'll see that the 1951 measurements qualify as an outlier across all the months. Right, so that's clearly an issue there. Okay, in 1951, that especially in the summer, the June, July, and August minimums are all in 1951. Right, and in fact, even the most recent data that's not even in this data set is not quite at that low level. Okay, so there are times in history when it's been even lower than what we've currently seen in Lake Travis. Yeah. So this is a very interesting thing. This is a very important part of analyzing data, I think, now. All the interactive graphics that are there, you can use them for pedagogical purposes because it helps students understand the connection between the data and the graphs.
Yeah.
I think oftentimes students just sort of think graphs appear magically.
Right. The software did it.
Yeah, somehow I don't know exactly what it is, but I'm going to tell you what the median is, okay? But when you start brushing a graph, interacting with a graph, then that draws those connections.
Right.
Okay, so we've now actually taken one of these points and said, oh yeah, this is where it's at in the data. So we can turn off that highlighting by clicking clear here. There we go. And maybe we want to look at a few other years here. Let's select 2 this time. Yeah, so now we got 1952, so it was a bad couple of years, 51 and 52. And then 64.
1964.
Yeah, and in fact, we'll see, though, that one of these years was, you see 2 of the dots highlighted in January, February, March, April, May, June, July, August. But then here...
Yeah, I see one of those years in September. It got a lot better.
Yeah, in September it got a lot better, right? And it was even up above the
what year was that?
Because
I see whenever you are pointing to that point, a little pop-up is telling me a little bit about that data set. About that data point.
About this point, yeah. Let's see here, yeah.
Row 10.
Row 10. So that was in 1952. So you see this sort of. If you look at this data, actually, it's a complete time series. You'll see that occasionally you get a monsoon. Maybe it's hurricane type weather in the Gulf of Mexico, but there's something that generates a massive amount of rainfall, and things can change very quickly. So if you don't like the level of Lake Travis today,
just wait.
Just wait. and it typically takes a massive rain event to get you out of a drought type situation like there was in 1951 and 1952.
Mm-hmm.
In 1964, though, you'll see that, if we hover over these, that's row 22 here. It was consistently low.
Yeah, like it was in 1951.
Like it was in 51. But we got some good rain sometime in either September, I guess, of 1952, and that really brought the level back. Okay, so that's, I think, illustrating one of the nice ways that you can interact with the data. That's something that is very, very important pedagogically. In terms of real-world data analysis, as I said, it's a critical skill.
Right.
Analyzing lots of data sets myself, that's something I have to have.
So if your students were making, let's go back to your original question about kind of what month would you like to visit Lake Travis?
Right.
What kind of response would you be anticipating, and what kind of things do you think you hope that they would be making when they're making that claim that they would be considering in their final interpretation?
Well, I would go back to the idea that I'd put forward and hopefully work the classroom discussion in the direction of, and that's what we want to go, and it's typically on the higher side with the least amount of variability.
Yeah.
Okay, so one of the issues that we see here, though, is that it's very variable.
Right.
Right, it's very variable. So the variability is roughly consistent, I would say, across the 12 months. So the best we could probably do in terms of making our decision would, it looks like probably May and June would be some of the best times to visit.
That's where especially after you were showing some of the outliers there. March looked pretty good, and May and June to me.
Yeah, the water's cold in March. So
yeah, that's true.
If you factor in the temperature as well as the level,
there you go.
Then I would suggest May and June as being some of your best months. But, So this is, a graphical way that you can look at this particular data set. And I always start with graphs, and I encourage my students to do the same. I think bad decisions are made, statistically speaking, if you don't look at a graph first. There is no analysis that I can ever imagine doing that should not be motivated by a graph. So that's something I really try to ingrain in my students. Graph first and then compute some numbers later, right?
Yeah.
So we might want to actually look at these numbers in a table now, and let me just show you how to do that real quick.
And I think that should be a general rule of thumb, that not only graph first, but integrate your reasoning about the graphs and numerical summaries, so that you're reasoning both from the statistical measure point of view as well as what you're seeing in the distributions whenever you graph it.
That's right.
Yeah.
That's right. I'm going to go ahead and turn off the highlighting again here, clicking the clear button. So now let's just compute some summary statistics.
Okay.
So all the numbers are under the stat menu, things like means, medians, and t-tests, and regression, and things of that nature. Summary statistics for columns here. Once again, I'm going to select all 12 of these. And we're just going to click compute. And now we get a nice table of output. Now, one of the things we've added recently, and something I think that's nice for classroom usage, is the ability to hover over rows and have those rows be highlighted.
Particularly if you're displaying this in a classroom.
Right,
Yeah.
right. Displaying in the classroom is very difficult. So if you want to have that ability to focus, having this row highlighting ability is nice. So that really is based on my own classroom experience. And one of the other things that we've added, if you want to think about when is the median level the highest and things like that, you can now sort this table very easily by clicking on these arrows.
Oh, that's nice.
Before I do that, let me just point out that StatCrunch sort of understands the way that certain things should be ordered, like January, February. It recognizes those as months and will order them correctly.
Right, rather than alphabetical.
That's right, yeah. Even if we didn't select them in this order, it would produce this ordering. But if we want to break out of the standard ordering and sort things based on median or mean level or anything like that, there we go. Okay, so now we've got it ordered, increasing. If we click again, we can get it ordered decreasing. Yeah. So the median level was in fact highest in June, as we saw in the box plots. It's if we want to go
May, March.
Yeah, there we go. That was your 3 months.
Yeah, it was.
So let's click here. All right. So we've identified June as the high median level. So if you think about your measures of spread that we saw, standard deviation, interquartile range, and things like that. There you go. We can easily see that the standard deviations here are very consistent, right? Now, one thing that is not produced by default in StatCrunch is the interquartile range.
Okay.
Another way to measure variability. In fact, my preferred way in most cases.
Yeah, especially if you're using box plots.
That's right. Yeah, if you're going to motivate these statistics using the box plot as the graphic, We can go down and include it. So you have several options here of other statistics that you can,
Oh, got it.
compute.
Mm-hmm.
So let's go down.
I think
and
there we go.
All right, hold on. Let's see if we can get rid of that one. There we go.
There you go.
We now have our IQR. Once again, we saw the consistency in the box plot, and in fact, the numbers here are quite consistent as well.
Mm-hmm.
And so that's something I think that's nice, to go from the graphic to the numbers that makes these numbers mean a bit more. Right?
Yes.
So the standard, we saw that the variation was roughly consistent, and when we actually compare these numbers, we see that, right, in the values that are here. Okay, all right, so that's, your basic table of summary statistics. So we know how to do box plots, we know how to do summary statistics now in StatCrunch.
Yeah, and in any kind of interpretation and claim that I might make, I would hopefully be using reasoning that I might do with the graphical, as well as reasoning from the statistics that have been computed for us.
Yeah, absolutely. I think that graphics is the first step, and then the numbers are the second.
Yeah.
And
Nice.
interpreting them correctly. Yeah.
Right.
For both, really, the graphics and the numbers.
Yeah.
Okay, so another thing I like about this data set is that it's a natural for thinking about correlation as well.
Okay.
So, since we do have measurements that are paired together here with the year,
With
right?
years.
Yeah.
Mhm.
So we can start thinking about what type of correlation do we see between the water level in January and February?
Okay.
And it's important to have students think about this question before you do anything with the software. I always ask my students, what do you expect?
Mm-hmm.
And then let's think about what actually is
Yeah.
From looking at the data. Were
Make a
your
prediction
expectations
first.
met? Yeah.
Yeah.
Were your expectations met, or did we learn something new here?
Mm-hmm.
So if you pose this type of question to a class, most people are going to think, well, if it was low in January, it'll be low in February. Typically, and so what they're describing, if we map that to the idea of association, we're talking about like a positive association, right? That's what most people would expect to see. If it's high in January, it'll probably be high in February, and so you want to think about that as you motivate that idea before you ever even look at a scatter plot, say.
Right.
So let's go ahead and take a quick look at a scatter plot. Let's actually look at January and February. All right, so we chose the scatter plot under the graph menu. So let's look at the January measurements,
It's our
and
X. and
February is our Y.
Okay.
Yeah. And let's go ahead and click compute. Yeah, so in fact, it's exactly what we expected, right? So there are some situations that it's very strong positive association here.
Mhm.
There are some outliers here, right?
Right, right.
There are some of these outliers. And, if we had a lot of time, we could actually discuss those a little bit, identify when these outliers occurred. We could simply do something like this.
Mm-hmm.
Then use the arrows here to navigate down to the selected row. So that was actually in 2010 was an outlier. Okay, and if you think about what's going on with that particular point, that's when the January measurement was low and the February measurement was high.
Yeah.
So higher than you would have expected. And the same is true for this other point here, which we can select.
Yeah, and it actually looks like a lot of the ones that seem to be outside of the general cluster of points seem to have that pattern, where it's low in January and higher
That's right.
in February.
That's right. And that probably has to do with weather patterns.
Yeah.
Right? There's some, moisture, some rain that comes in that raises the level a little bit in February.
Mm-hmm.
But overall, it's what we expected to see. It's a strong positive association, maybe with a couple of outliers that could impact things here. January and February, we saw what we expected to see. So would the same be true if we looked at all the pairwise associations?
Okay.
Okay, so, January and February, they're close together in time, so it's likely they would be positively associated. But how about January and March, or January and June, or January and...
January to anything.
Yeah, to anything. Now, we got to remember, of course, that December is actually close to January.
Right.
So about as far from January as we can get would be in June or July, right? And then we're actually just getting towards the end of the year. But let's think about how we would do that. So I like something called a pairs plot. And this is something I've started showing my students in class in the last couple of years, actually since I've come to NC State. With data sets like this is just one of the examples that we used for the pairs plot. The beauty of the pairs plot you can select all the data, January through December.
Okay.
Click compute.
Oh, wow.
All All right, so now we get a matrix of scatter plots with all the axis information. And on StatEd, we always like to see things labeled on the axes, right? But this is a situation where we're trying to put a lot of information on the screen at one time. So if you think about it, we've got like 144 scatter plots here. So the one that we were looking at before was this, where January was on the x-axis and February was on the y-axis. You can actually see here the two little points that we were looking at, identified as maybe outliers in that picture. And this is really a triangular matrix of scatter plots. Lower or upper, you can look at either one.
Or symmetric, yeah.
Yeah, and so do we see any information here that would suggest that the level of correlation decreases over the year? I think we just think about that January and comparing that to some of the other months. January and February, we saw a very strong association.
Right.
And then you can come on down and see January and March in the next plot. And I think even there you can already see a little bit more variation about the linear trend.
Yeah,
right?
I'm seeing a larger clump.
Yeah, and same thing in April, and it's much larger than in May.
Yeah.
June, it's July, it's probably at its peak, or maybe even August. And then September we see a lot of variation. And even January to December, there's a lot of variation. Now, we do have to remember here that that's the December at the end of that particular year, not the December at the next year.
Next year,
right? So, that is 12 months apart, okay?
Right.
But yeah, so we do see as you move away from January that the other water levels, the correlation with that January measurement is dissipating, right?
Yeah.
And dissipating quickly.
Yeah. Okay, so we have this all these plots and looking at the different correlations. Where would we go from here?
Yeah, so the next step, of course, would be to compute correlation. So let's hop over here under the stat menu where the numbers are located. Once again, under summary stats, we'll choose correlation. I'm going to select all the columns, and we're going to get the corresponding correlation matrix to the scatter plot matrix, the pairs plot that we were just looking at. Let's go ahead and just click compute. And now we see it. By default, it's only a lower triangular matrix, but we can now quantify those correlations that we saw back over here in the scatter plots. January and February is in fact very highly correlated, 0.978, the correlation coefficient. And as we noted, as we move through the year, it gets lower and lower, right? So in December, the January measurement is
right, and that corresponds to
the scatter plot.
The scatter plot down here. Yeah.
The January, December scatter plot. I think we've got them a little bit out of order now, but yeah. So that's the corresponding correlation matrix.
That's a nice use of this data set.
Yes. Yeah. It's a great way. Once again, graphs and numbers, and drawing the connections between the two. So that's just a really quick run through of some of the things that you can do in StatCrunch. And with this particular data, these are some of the things that I do in my own class.
Yeah.
And so there's lots of other things you can do. It's a rich data set, though. You can do basic box plots and things of that nature. You can then talk about correlation. There are very few data sets that allow you that. And this particular format is one that I use for that purpose quite a bit.
Right, right.